Hello everyone, today we will talk about interrupts. ARM architecture defines interrupts as a signal to the processor emitted by hardware or software indicating an event that needs immediate attention. The interrupt signal causes a temporary stop to what is happening in the program and serves the interrupt. In ARM architecture there are interrupts originated by the hardware and exceptions originated by software. For example, invalid access to the memory location. Cortex-M processors provide a unit dedicated to interrupt management. This is called Nested Vectored Interrupt Controller, NVIC. NVIC is a dedicated hardware unit inside the Cortex-M based microcontrollers that is responsible for handling exceptions. All interrupts, including the core exceptions, are managed by the NVIC. A dedicated program controller named XT, External Interrupt or Event Controller, is responsible for the interconnection between the external I/O signals and the NVIC controller. XT controller consists of detectors for generating event or interrupt requests. STM32 microcontroller provides a variable number of external interrupt sources connected to the NVIC through the XT controller, which in turn is capable of managing several XT lines. The number of interrupt sources and lines depends on the specific STM32 board. In our case, STM32F7, up to 168 GPIOs are connected to the 16 external interrupt event lines. You can find more information about NVIC in RM0410, chapter 10 and 11. To solve the problem from the previous video, let's open the project.ioc and look for the pin PC13 related to the user button. In the system core, click on GPIO and you can see that the configuration is external interrupt mode with rising edge trigger detection and no pull up or pull down because the board has an external resistor to do that. Now, in NVIC tab, we have to enable the interrupts by checking the XT line interrupt box. So, the already learned process of generating the code, click on Generate Code button. Open the project in Kale. And look for the STM32F7xxit.c file. Here we can see that CubeMX has implemented the code for the interrupt handling function. And now we have to implement the whole GPIO callback function with the behavior we want. In this case, reading the button to toggle the green LED. If you activate two interrupts from pins with the same number on different ports, it will be the same ISR that responds. Also, the XT only has 11 lines, so from pin 11 to 15, everything goes to the same interrupt. One way to differentiate between these pins is to use this if. Let's compile and flash to see what happens.